this location, and you'll see that all of these are approximately 30. But based on my measurements, you see that there's some variation there, okay? So let's go to our angle in radians, and the angle in radians is going to be based on the following theory. So the theory is down here. All right, A tan y over x, okay? A tan y over x. We're looking for the angle. And Microsoft Excel actually produces the angle in radians. So I'm going to go ahead and tap in here. I'm going to say equals to, and I'm going to type in A, T, and look, I have arctan, arctan2, hyperbolic, arctan, which we're not going to worry about. But arctan just returns an arctangent of the number in radians in the range of a negative pi over 2. That's 270 degrees. You know, it's like going around. And 2 pi over 2. So we could use that, but I would like to use the arctan2. You'll see that all you need is your x num and your y num. So I'm just going to go back, select on arctan, and with my arctan, I'm going to select my x number, and x is right here. It's A2. Okay, so we have A2 that we're going to select in place of x num. Now you have your y num. So you see video analysis y, that's our y num. Ah, I get it. Yes. I'm not, yeah, okay. So angle in radians, that's the first angle in radians, okay? It's really small. And of course, we're going to fill this because we don't have to do the formula again and again and again, like I'm making you guys do in class for experience. And I want you guys to know, well, I want you to notice something. You have this 3.1415927. This is what we call pi. All right, these are in radians. This is 3.1415927 pi. And so what does that mean in terms of the circle? Well, in terms of this circle, and I'll just go to the, I could duplicate this page, or I could just work on this page. But that means that this side is pi. All right. So that is 3.14159 ... Decimals never repeat, okay? If I keep going around, it's going to end up being 2 pi over here. At the top, this is pi over 2. And then out at the bottom, this is 3/2 pi. So these are angles. So this theta here, this is an angle, and we're measuring it in terms of pi's, or better yet, radians, okay? So let me just get out of this, come back here. So we're at 360 degrees. Now look at what's happening. It's going to a -2. If we go in here and we look up arctan again, I don't know if I can do it here, nope, A tan, and I select on that I, look, it says returns the arctangent of the specified x and y coordinates in radians between a -pi and pi. So that means that it goes from a -pi all the way over to pi, excluding a -pi. So it's measuring from a -pi, and then it's going all the way around to pi. Interesting. I'm thinking that it's measuring from the positive x-axis over to -pi, and then it's measuring over to the over to pi, and then it's measuring from the positive x-axis to a -pi. Okay, so that's my interpretation of that. So let me just get rid of this stuff that I placed in here. So down here, we want to fix this. The way we're going to fix this is like this. We're going to add 2 times pi, pi. Okay. And so you'll see now that the value is a little bit higher than 3.14. That just represents that the angle is going below 180 degrees. So I'm going to fill down, and you'll see that I end up with about 6.